Hi, this is Professor Fernandez. In this video, we're going to work on example A2.2 from Calculus to Simplified. So in this example, we are going to evaluate this integral using the tabular method. So here's how this goes. In the tabular method, you create a table. So different books do it different ways. In Calculus to Simplified, I chose to do it horizontally, mostly to save space, honestly, as I wrote the book. But also because we make tables values, x values and y values, and a lot of times we do this horizontally, like with an x value over here and then with f of x values over there. So I thought maybe we have some experience doing this, and I'll keep the landscape orientation. Okay, so in your table of values, right, remember that we're doing integration by parts. So integral of u dv equals u times v minus integral of v du. That's our standard integration by parts formula. And first of all, there's a rule of thumb that I discussed in the book and discussed elsewhere for choosing u. And that rule of thumb is I late. Right, so you want to look at your integrand. In this case, that's x cubed cosine x. And you want to, as a rule of thumb, choose u to be the function that occurs first going down this list. So in here, we have inverse trigonometric functions. We have logarithms. We have algebraic functions. We have trigonometric functions. We have exponential functions. So if you choose u to be the first function that's on this list in your integrand, when you eventually go over here to the integral you're left with in integration by parts, you differentiate u. That's part of what du is. So for example, if you differentiate an inverse trig function like arcsine or inverse sine, then you'll end up with something else that will help you maybe do the integral later. When you differentiate an algebraic function like x cubed, you end up with 3x squared. That might help you later for this other integral. So that's the I late acronym and rule of thumb. So over here, we have an algebraic function that's x cubed. That's over here. And we have cosine x, that's a trigonometric function that's over here. So the rule of thumb, the I late rule of thumb tells us we should choose u to be x cubed. And then dv will be everything left in the integral, right? So that's our left-hand side integral. Now, if we wanted to do integration by parts, right, we would go off and find du and integrate dv to get v and all that stuff. But this video is about the tabular method. So having identified u and having taught you a sort of a rule of thumb for how to find u, here's how the tabular method goes. So I'm going to put my u here, that's x cubed, and I'm going to put my dv here, that's cosine x. Great. And in the tabular method, now we're just going to differentiate. In the first row, you just differentiate your u. So derivative of x cubed is 3x squared. Derivative of 3x squared is 6x. Derivative of 6x is 6. And then I need one more row here. Derivative of 6 is 0. Once you get to 0 in your u row, that's where you should stop your table. Now, in the row below, we're going to do the opposite. Instead of differentiating, we're going to integrate. So integral of cosine x is sine x. Integral of sine x is minus cosine x. Integral of that is minus sine x. And then integral of that is cosine x, right? If you're ever in doubt, you can kind of differentiate. If you're, like I am, more used to differentiating, you can say, oh, derivative of cosine is negative sine, and then just check your work to make sure that all of these boxes are accurate. All right, so now we have filled in our table for our table method for integration by parts. Now here's what we're going to do. We're going to say, and this is literally the tabular method approach, we're going to say, hey, this integral is equal to, and then first thing we do is we're going to multiply diagonally. So these, the product of these two boxes here, and we're going to put a plus sign. So equal to plus x cubed sine x. Great. And now we're going to multiply diagonally for the next box. The product of these two, and then alternate the sign, put a minus. So minus, and then 3x squared times negative cosine x. And you just keep going like this. So next one, I'm going to multiply this diagonally, alternate the sign, plus. So we got plus 6x times negative sine x. And then finally, one more box here. We multiply these two, alternate the sign, negative. So minus 6 cosine x. And then we need our plus c, because that's an indefinite integral. Okay, the rest of this is just simplification, but you can see that we've avoided doing the UV minus VDU and integration by parts. And actually, in this particular integral, we would have had to have done this 2 more times, use integration by parts 2 more times. And so the tabular method to integration by parts saves time, right? So you set up the table. To review again, the first row is the U you chose, and then just differentiate. The second row is the dV that was left over by your U choice, and then just integrate. And then you start doing these diagonal products, starting with plus and then alternating the sign, and then writing out what those products are. And that's, by a theorem that I discussed in the book, is the same as potentially having to do integration by parts multiple times. Gives you the same answer. Great, see you next time.